We're given three functions f of x. Across the top of this table, we have x cubed, 2x, and x minus 1. So I want to ask, what would we do to undo the work of the given function? So for instance, if we have an x cubed function, if we plug a value in, such as 2 for x, and cube it, we're going to get 8. Now, if I want to go back, I started with a 2 and I got an 8. If I want to go backwards and start with the 8 and get back to the 2, we would have to do a cube root. So the cube root of x, this function that would undo the work of an x cubed graph, is the inverse function. So if you plug in an 8 now, if you take the cube root of 8, you're going to get back to 2. So the inverse of x cubed is the cube root of x. If we start with the function 2x, every time we plug in an x value, we can see we're doubling. So if we plug in a 3, 2 times 3 is 6. So if I want to now go backwards and start with 6 and get back to that original x value of 3, I would have to take half of 6, or divide 6 by 2. So the inverse of 2x is 1/2 x. Because if I plug it in now, if I plug the 6 in and I take half of 6, it's going to get me back to 3. So that means 1/2 x is the inverse of 2x. Finally, if we have x minus 1, so if I start with a value such as -6, I'll start with -6 for x, subtract 1, and I'm going to get -7. So obviously this function is subtracting 1. Well then if I want to get back to where I started, if I want to start with -7 and get back to -6, I'm going to have to add 1. So the inverse of x minus 1 is x plus 1. So if I plug a -7 back in here for x and add 1, it's going to get me back to the -6 that I started with here. This is the idea of inverses. So the function that will quote-unquote undo the work of a given function is the inverse function. The notation that we use, this is our notation for an inverse function. We read this f inverse of x, or the inverse of f of x. So since f inverse of x undoes whatever f does, if we compose a function with its inverse, we will get back to x. So that's another way of saying if I put an x into my function f of x, and then I plug that answer back into the inverse, I'm going to get back to my original function x. So here, if I compose two functions, a function and its inverse, so if I take f of f inverse of x, I'm just going to get back to my original x value. And the other way as well. If I start with f inverse composed with f, if I put an x value in here into f and then plug that output into its inverse, I'm again going to be left with x. Now we want to note this notation, do not mistake that -1 for an exponent. So we want to just note here that does not mean 1 over or the reciprocal of f of x. That's a big distinction to make. So this -1 is not an exponent, it's actually a symbol connected to the function and the x that means inverse.